This file right here is a RAT or reverse shell which works through Minecraft. That is right, it will connect to a Minecraft server and then we'll be able to remotely control the computer from within Minecraft. You can even have multiple players connected to the server, controlling the computer together. On the left, I have the Minecraft server. Top right, I have a Minecraft client connected to it, and bottom right, I have the target PC. Let's execute the agent on the target computer and observe what happens. As you can see, up on the Minecraft client, we see a message that the IP of the target computer connected. Now, if I open the chat and type in exec and then a command, for example, who am I, and press enter, as you can see, we literally executed who am I within the Minecraft chat, remotely controlling the bottom right Windows computer. Look, I can even list files. Or even write to a file if I wanted to. There the file appeared. Keep watching because I will show you exactly how to set all this up from start to finish. Okay, here I am on Windows. Before we get started, just a quick reminder, the goal of this video is obviously educational only. Please don't try to do anything stupid. Now basically what we need to do in order to achieve this effect is create a Minecraft mod. And in order to do that we need to download a few things. So let's get started. I'll open a browser. And the first thing we need is a Java development kit. As you know, Minecraft is written in Java, and in order to mod Minecraft we need to write some Java code. And to write that Java code we need a Java development kit or JDK. So search Temurin JDK, click this, select JDK 21 and download for your specific OS. I'm gonna download for Windows. Run the installer. Over here, make sure to select will be installed on local hard drive and hit next and hit install. Next, we need an IDE where we are going to write our Java. For that, we are going to use IntelliJ IDEA. Hit download and download. Run the installer and go through it. And hit finish. Now we are going to be using Fabric to create this mod. Fabric is basically a tool chain to create Minecraft mods. So let's go to fabricmc.net, go to develop and online template mod generator. For name, let's do rat mod. I'll hit use custom ID and just do it like this. On package name, let's do com.heptasec.ratmod. For Minecraft version, I'm going to select 121.1, and in these settings here, I'm going to uncheck these and check this one. Now hit download template. Now let's cut this. I'm going to go to desktop. You can create your directory wherever you want. Let's create a folder, call it project. In here, paste this and extract it here. Let's rename this to rat-mod-121.1. Now let's open IntelliJ IDEA. And now let's hit open, go to our project, let's select this, choose this project, and our project is loading. If we click this icon here where it says build, we can see it is downloading some stuff and just setting up our project. Okay, once you get build successful, you can continue. And if you didn't get build successful, or even if you did, you want to make sure you go over here, go to project structure, make sure both of these say 21 like this. Now go to settings, build execution deployment, build tools and Gradle, and make sure over here you have Gradle JVM and again you have SDK21. Now you should be able to expand over here and see your Hello World mod. What I will also do here is go to these three dots, go to appearance and uncheck this one. Also click here, go to settings, go to editor, general, and just select this so that I can change font size with scroll, so I can zoom in for you. I can click this to hide it so we have more space. Now what I'll do is I'll go to mixin over here, double click this example mixin and control click this Minecraft server. Hit accept. Now open a terminal from right here and do ./gradle w gen sources and wait for this to run. Once that's done and it says build successful, you can go to choose sources right here and select the one that says sources at the end. So here you can see this one says -sources at the end and hit open. Once that is done, we can close this. Now we can hit this button here which just says Gradle and just hit this button here. If you don't see Minecraft client, Minecraft server up here, try restarting your IntelliJ IDE. And now if you go up here, you should be able to start your Minecraft server and Minecraft client. So let's try that. Let's hit run on the client and let's hit run on the server. And here you shouldn't be getting this. I'm getting this because I'm running this in a VM. For you, the Minecraft game should just pop up. Here we can see our code run, and we also need to agree to the EULA to run the server. So let's open run. Here is EULA.txt and let's set this to true. There we go. And now if we run our server again, and there we go, our server has started. Now you can use your client that you started from right here, but I'm going to just use this one. And now if you hit multiplayer and direct connection and type in localhost, oh, that might happen. We need to go to server.properties. Let's just turn online mode to false. And now we need to restart the server. Okay, our server has started, and now if I hit direct connection again and join server, you can see I am in the game. If you have started your server and your client, and you have been able to connect from your client to your server, we are ready to start coding. Okay, now let's get to developing our mod. Let's close run and expand source, Java, and let's create a new package at the level of the rat mod package. So right click here, new package, and let's call it utils. Now right click it, new, Java class, and let's call it TCP server. We're going to use this TCP server to communicate with the agent which runs on the target computer. Now let's define some fields in our class, one for port and one for the Minecraft server object. Hit tab here to create the necessary import, and let's call it MC. Let's also define a field for our client writer. Again, hit tab to apply the import. We're gonna use this to write data to the socket, you will see in a moment. And finally, let's define a field for the client IP. This field is going to hold the IP of the agent that connected to our TCP server. Now let's define a constructor and let's initialize our fields. And now let's define our method which is going to start the TCP server. Let's set up a new server socket. Again, hit tab to create the import. And here we will use our port field. Now here we have an error that we have an unhandled exception, so let's make sure to handle it. Okay, now that we have started listening on this port, let's print a message. And now let's create an infinite loop where we accept connections indefinitely. Once we have accepted a connection, let's first set our client IP field to the IP of wherever this connection came from. Next, let's set our client writer with the output stream of our socket. And now that we have a connection, let's broadcast about it to all users in our Minecraft server. This will appear in the chat in the Minecraft server, and every player that has connected to the server will see it. And we can do it the following way. There we go, we're going to have the client IP in square brackets connected. Now let's make sure we can also read data from the socket when the agent on our target PC sends back data to us. In our case, that is going to be the output of the executed command. And now we need to iterate over all lines that are sent back from the client and broadcast them in the server chat. We're basically reading lines until there are no more. And once we have a valid line, let's just broadcast it. We can use the same format as this one here. However, instead of connected, let's print which IP is the reply coming from, and let's add the line here. But here we're gonna have an error, so we just need to set this line to a new variable first. There we go. If we happen to catch an error when accepting the connection, let's ignore it. And let's add a finally block where code here will run when our client disconnects and this socket is closed. So let's make sure to broadcast the appropriate message here. Let's do client IP disconnected. And let's make sure to set our client writer to null and our client IP to null as well. If the socket is closed, we no longer need these. Now, to keep things simple here, we are going to only accept one client connection. Obviously, we could configure it to set it like a C2 where multiple agents can connect, and we can then select which one we want to control, similar to our C2 development series if you want to check that out. But here, to keep it as simple as possible and as little code as possible, let's just accept only one client. So let's do a check here. If our client writer is not null, so if we have a client which we are communicating with, let's just continue. In that case, we are just going to accept the connection and do nothing with it. And only if the previous connection that we had reaches the finally block and this is set to null, only then are we going to accept a new connection. And finally, let's make sure that we are running this in a new thread, because we don't want this TCP server to block our entire mod. Let's call it TCP server and let's start it, and let's just take all this code and put it inside. Now let's expose another method, which we're going to call connected, and it is just going to return whether we currently have a client that is connected and is actively interacted with. If you remember, we know this based on whether client writer is null or not. If it is not null, then we have an active connection. If it is, then we don't. So let's return whether client writer is not equal to null. And finally, let's expose another method, which will be used to send actual commands to the agent. Let's do client writer.write, and we are going to send the command that was passed and a new line. And let's also make sure to flush to send it immediately. Now here we need to handle some exceptions in the case where we couldn't write to the client. So let's do try, put this code in the try statement, and let's catch and ignore the IO exception. If there was an exception, let's just set client writer to null, which if you remember means that we currently don't have a connection. And if we didn't have a connection to begin with here, let's just make sure we don't even try to write to it. Okay, great, with that our TCP server is ready. Now let's go to our ratmod.java file. Let's remove this from onInitialize, we are not gonna need the logger, and let's define a field for our TCP server. Hit tab here to import our package that we wrote, and let's call it TCP server. And here in onInitialize, what we are going to do now is we are going to run the start method of our TCP server class. We are going to run this method when our Minecraft server starts. So whenever our Minecraft world starts getting built, we also want this TCP server to start listening. We're going to do that using the following code. Code in here is going to execute when the server is started. So here, let's set our field to be a new TCP server. Here we need to choose a port. If you remember in the constructor here, we need to pass in a port and a Minecraft server object. So let's do port 5000 for example, and let's pass in our server. After we have our new TCP server object, let's execute the start method. Okay, our TCP server functionality is now defined. What is left is to actually register the exec command that you saw us use earlier. So the Minecraft server actually recognizes it as a command and knows what to do when a player inputs that command in their chat. To do that, let's create a new Java class in our utils package, and let's call it sendCommand. And here let's define a method which will register the command. We'll do it like so. We will need this command dispatcher type, which we are going to pass from here in a moment. But for now, let's just use it. We do it by saying dispatcher.register. And here we do command manager.literal. And here is the name of our command. Let's call it exec, as it was in the demo earlier. Now we need to define an argument for this command. If you remember, when we type exec, we had a command argument, which was given to us that we need to input next. So let's do .then and set a command manager.argument. And let's call the argument cmd. If you remember, that was what it was called. And now we need to tell it what are we going to execute when this command is input. We can do this by saying .executes And here basically what we want to do when a user runs the /exec command and passes a cmd or command is to call this sendCMD method which we have in our TCP server. It is going to write it to the stream and flush, if you remember. So let's first retrieve the command that was passed. And once we have it, let's run TCP server.sendCMD. Now within this class we don't have an instance of the TCP server. However, if you remember, in the ratmod.java we set the TCP server as a public static field, which means we can access it in other classes, and we can access it without creating an instance of ratmod, but rather using ratmod itself. That means we can just do ratmod. That will import our package .tcp server, accessing exactly this field here, .send command, and we will send this command. Now when we are executing a Minecraft command, we also need to return whether it was successful or not. So in this case it was successful and we will return 1. 1 means success. However, how do we know if it was not successful? Well, let's handle that case. Before doing that, let's make sure to check whether the TCP server object that we have here is null. Or if there is no client connected. If you remember this method that we have here, it is meant to tell us whether there is a client connected or not. If there is no client connected, then let's send an error to the user that was running the command, which we can do like so. We are sending to the user no client, so that they know we currently don't have a client that is connected to our server, or an agent. And let's return 0, which means this command was not successful. Let's make sure to have a bracket right here and a semicolon right here. And with that, our method which registers the exec command is done. Now what is left is to actually call it in order to register the command. We can do this in our ratmod.java class using the following code in our onInitialize method. Right here we are going to call our register method, which is static. That is why we access it by using the class itself, and we will pass this dispatcher here, which we use in order to actually implement our logic here. And with that, if I didn't miss anything, our server mod is done. Now it is time to write our agent, which is going to be executed on the target computer. We will write it quickly in Python. Let me create a new folder, call it agent. And let's start VS Code in here. Let's create client.py. Let's import socket and subprocess. And let's define our IP and port. These IP and port are going to be the IP and port of the TCP server that we're going to be running here in parallel with the Minecraft server. So let's do host and let's set it to localhost. And for port, let's set it to 5000. If you remember, that is what we decided to use as a port right here. And now I'm going to use the exact same execute CMD function which I showed in our Discord remote access tool video. If you're not sure how that works, I would suggest going back and watching it as well after this one. Here it is. We are going to be opening a new PowerShell process, and then this is just a function which is going to interact with this PowerShell process. We are going to be passing it a command, it is going to be executing that command in this PowerShell process, and it is going to be returning us the output, which the PowerShell process gives us. Now let's connect to the TCP server. Now that we have that, let's initialize a buffer variable. And let's set up an infinite loop where we are going to be receiving commands from the server, executing them and sending them back to the server, or sending the output of them back to the server. And now let's receive a chunk of 124 bytes. Now this receive function is blocking, and this code is going to hang until the server doesn't send a command which we want to run. Pretty much our whole client script is going to hang here until we send a command. And once a command is sent, we over here on the client are going to decide what we want to do with that data which was received. In our case, we want to execute it in our PowerShell session here and send it back. So let's define that. But first, let's do if not chunk break. Basically what that does is if we receive an empty byte string here and this condition is met, we break out of the loop, because if we receive that empty byte string, it means the remote connection was closed cleanly. Now let's add this chunk to the buffer. And we are doing this because a command may come in pieces. And now let's look for a new line in the buffer. If we have a new line, this means we probably have a full command. If we do, let's pull out this line and leave the remainder, if any, in the buffer. Now let's make sure to decode the line and save it as our command. And let's execute it and save the result. If this doesn't return anything, let's set the result to be executed command with no output. And finally, let's send the result back to the server. Okay, let's save this, and with that, our agent is done. Now let's go to IntelliJ, and if we didn't forget anything here, our server should start up. So let's hit run. Okay, our server seems to have started, and we also have this. Our TCP server is listening on port 5000. Now you can start your client from here too, but I have mine over here, and let's connect to localhost. There we are in the game, and now let me come over here in Visual Studio Code. Let's open a terminal and let's run our client. As I'm running it, I'm going to open, and as you can see down in the chat, we have the IP of the agent and connected, which is going to be localhost in our case. Now let's see if we have the exec command. As you can see, we can auto-complete it with tab, and once we hit space, it tells us that we need to choose our command here. So let's try who am I? And as you can see, when I hit enter, we received back the output. If I do exec print working directory, we can see we are in desktop/agent. Let's do cd ... and let's do exec ls, and we can see the files on the desktop. Let me do something and let me minimize these. Let me open the client and let's do exec echo test into test.txt. And as you can see, our file appears right here. We were able to create a text file on our desktop straight from Minecraft. We haven't done any modding of the client, which means you can connect to this server with any client you want. And your friends can also connect to your server with their normal clients. Now let me stop this. And if you want to run this Minecraft server outside of IntelliJ IDEA, we can open a new terminal and do ./gradle w build. And once it says build successful, we can go to build right here, libs, and right here we have our mod jar file. So what you would need to do now is set up a fabric server and add this jar mod file to the mods folder. If you're interested in doing that, I would suggest looking up how you can set up a fabric server and how to add mods to it. Also, to turn the Python script into an exe agent like it was in the demo, you can use PyInstaller. I have covered that in the Discord remote access tool video as well. If you followed along, you should now have a modded Minecraft server that can remote control PCs. I encourage you to extend this mod and set it up as a full C2 server, with multiple agents being able to connect and a command that allows you to switch between them. If you have any questions, leave them down below or over at the HepSec Discord community. If you are interested in more videos about remote access or coding similar tools, here is the playlist. Till next time.